So is 0.9999999 and so on equal to 1? Well, let's find out in this video. So I'm going to do this in two ways. The first one is an elementary method which anyone can understand, and then the second one requires a little bit of geometric progressions. Now I'm going to let some variable y to be equal to this recurring decimal 0.999 and so on, and let me call that the first equation. Then I'll multiply this equation by 10. So I multiply that by 10, so I have 10y, that's going to be equal to 9.999 and so on. I'll call that equation 2. As you can see, I have 3 9s here because I have an infinite number of 9s, so I can maintain any number of 9s that I want here. Now, interestingly, if I get the second equation, I subtract the first equation. If I subtract these two equations here, I'm going to eliminate the recurring decimal, and that's the beauty of using this method here. So I have 10 minus 9y, that's going to be, 10 minus y, that's 9y. And if I get this minus this, I get just 9. And if I divide both sides by 9, so I divide by 9, I get y as 1. And what is y? Y is this thing here. So I can conclude that 0.999 equals 1. Okay? So let's try it out using a different approach. So for the second approach, I'm going to get this number here, and I write it as a sum. So I'll write this as 0.9 plus 0.09 plus 0.009 and so on. You get the trend, 0.9, 0.09, 0.009, just like that. And of course, this is the same as 9 over 10 plus 9 over 100 plus 9 over 1000 and so on. Okay? As you can see, I can actually factorize out 9 from each of these. So I have 9 into 1 over 10 plus 1 over 100 plus 1 over 1000 and so on. Okay? Now you notice that what I have here inside the brackets is actually a geometric progression. So that's a geometric progression with the first term. The first term of this progression is 1 over 10, and the common ratio, if I get this divided by this, the common ratio is actually 1 over 10. You can see that every term differs from another by a term, 1 over 10, 1 over 10. That's being multiplied to get the next term, alright? So, thankfully there is a shorthand formula for finding the sum of an infinite geometric progression. Also notice that since the common ratio is less than 1, the sum of this geometric series converges. In other words, when you add these together, it does not increase infinitely, but it seems to be tending to a certain number. So let's find out what that number is. Now, the sum to infinity is given by the formula a over 1 minus r, for r less than 1, where the sum converges. So in this case, right, we'll have a, which is just the first term, 1 over 10, divided by 1 minus r. R is 1 over 10 as well. So that's what? 1 over 10. As for this, divide by, just say divide by. This is 1 minus 1 over 10, which is actually 9 over 10. Yeah, that's 9 over 10. So in the end, what do we have? Just have 1 over 9. Okay? So that is the sum of all this. This equals 1 over 9. And then I'm going to substitute that back here. So we actually have 9 times all this here is given by 1 over 9. So times 1 over 9, which still equals a 1. Okay, so I hope this convinced you that indeed 0.999999 to infinity is actually a 1. Thanks for watching this video. If you like it, give me a thumbs up, leave me a comment to let me know what you think, and I'll see you in my next video. Thanks.